vulnerabilities, we cannot generate data patch. The reason is mainly because they involve complex conditions. For example, if in ShieldGen, we only sample on individual fields. We don't look for the complex conditions such as one field must be greater than the other, or the combined length of two strings must greater than certain size. At the end, we also evaluated the effectiveness of ShieldGen plus Tupni. So we use Tupni to reverse engineer the format of WMF attack instance. Then we use a parsed WMF attack and feed it to the probe generator. And we obtained a high quality vulnerability signature for WMF. Okay, so uh, let me conclude my talk. Today I present the problem is to automatically generate vulnerability signatures for unknown vulnerabilities. And the solution is we want to combine two systems together. One is a ShieldGen, the other one is Tupni. What Tupni does is Tupni can reverse engineer the input format by identifying fields, record sequences, record types, and constraints, and aggregate them together. And the ShieldGen will leverage the format of initial attack instances and construct a new attack instance and use a zero-day detector to guide the search to find the vulnerability signature. And we have a working prototype based on Tupni and ShieldGen. At the end, we can use a working prototype to generate a high-quality vulnerability signature efficiently. Thank you very much. This is the end of my talk. Please, if you have any questions.
At the beginning of the talk, you said that you only saw 20 vulnerabilities 0 day in like 1 year. What like isn't it more efficient like for a person to analyze only 20 vulnerabilities?
Uh, no, the problem is when you have vulnerability, when you have a zero-day attack, particularly when you have a warm attack, if it takes 4 days or 7 days to do the manual analysis, it could be too late. You want to generate a signature or filter that can be deployed immediately when you observe the zero-day attack. It's not the number of attacks, or it's not the manual analysis can handle that in 3 years. It just takes so long for manual analysis to generate a protection filter when the attack is observed.
Turn your microphone on, please.
It's very easy to generate a patch because you have found where the program is run. Is that true? Or?
No, actually,
No?
from my understanding, generate software patch is much harder than generate this is so-called data patch. Yeah.
What does data patch mean?
Data patch means it's. I give an example here. Is I think. By the way, data patch is a term I think created by Helen Wang. Yeah, and data patch you can think about it, it's a vulnerability predicate on the input fields. As here you have a specification of the input, then you create a condition saying if the input look like this, I should drop it. I should throw it out.
Typically, for SQL injection, you don't check the other definition.
Yes.
So then why is it called a patch? Why is it called a data patch?
I think it's just want to draw analogy between data and software. That's why I say that's a term created. Yeah, it's created by Helen. Yeah. Yeah, I mean it's hard. I mean it's different because for data patch you assume you have this spec, and you basically look at the inputs. There are like this is why we do it in ShieldGen. But for software patch, even you know where is the condition, but no, I don't think you know the condition. Actually, Bouncer, there's a related work on this. But they also try to generate the input filter. Yeah, for program probably much harder. Maybe Xiang Yu can answer that. How to generate software patch? That seems pretty hard. Yeah.
So I'm curious. So when you so you said that when you use GAPA as the specification of format and you use that as the input to ShieldGen, you see some false negative.
Yes.
Did you see similar false negative cases when you have Tupni combined with ShieldGen? Does Tupni actually give you wrong specification that lead to the false negative of vulnerability
Oh,
signature?
for that one, actually, our evaluation.
So you
is,
just briefly said that it is good and highly
yes,
accurate. And,
yes, yes.
but-
That one actually Tupni also give us the similar. I say it's good is because it's comparable with what GAPA can give us, and that false negatives is a limitation in ShieldGen in some sense. Since ShieldGen does sampling of individual fields, and if you for example, one false negative in WMF is WMF has two versions, and basically one field may take two possible values. If you take either value, it will trigger the attack, and all be valid. If you do a sampling, it's really hard to find the second value, and if you don't find the second value, our vulnerability signature will say, oh, this field must take this value, and that will give us a false negative.
If you go to upper class Boston, people speak very differently than if you go to, lower class Dorchester or something like that.
Have you tested this like outside a lab?
Your social experience.
Have you tested this in like real networks?
On real networks, no. What do you mean real networks?
Like, have you ever tried it on a 0-day, like a recent 0-day? I don't know, a recent worm or something that has detected and generated a real signature, or it's just?
Oh, we only test on the three case studies like a slammer, SQ, the slammer. Oh, this means so long. Like, those blaster and the WMF. Yeah. Yeah, but both systems, ShieldGen and Tupni, actually currently are taken by antivirus teams inside Microsoft to analyze attack and to generate a signature that can be used by a virus analyst to derive the signature, the input filter.
Organic gardening in California. Those are organic gardens.
No, let's
Thank you.